Okay, in this module, I would like to talk about how to use mathematic way to describe the standing wave. That is nothing but a superposition of the electromagnetic waves, because the light is essentially the electromagnetic wave and it is transverse wave, so which can be superposed. Yes. Here I'm gonna give a rigorous mathematical derive. Here E, which is the electromagnetic wave formula, is a function of x and t. X is the position, t is the time, where epsilon hat describes the polarization. E module gives the amplitude of the electromagnetic waves. K describes the propagation direction, which is the k vector. This is a wave number. And the omega is the frequency of the light beam. And these are the four key vectors that can fully describe a electromagnetic wave, which is the light in our case. Now, let's, since we already have the formula of the electromagnetic wave, we can superpose two counter-propagating light beams to form the standing wave, and we're gonna use the mathematical way to describe it. Okay, let's say beam 1, we have E1 equal to epsilon 1 module E1 E to the power of minus I K1 x minus omega 1 t. And beam 2 gonna be similar. We just need to change the subscribers. Yeah, E2 equal to epsilon 2 module E2 E to to the power of minus I minus k2 x minus omega 2t. Here I use minus k2 with respect to k1. That is because k describes the direction of the propagation, and I use minus sign to say these two beams are counter-propagating to each other. For simplicity, we can let epsilon 1 equal to epsilon 2. That means the two beams have the same polarization, and we also set the amplitude to be the same, and we set k1 equal to k2. That is the number, but the direction is different. Omega 1 equal to omega 2 means they oscillate at the same frequency. We set E1, E2 to be 1. So E1 vector plus E2 vector therefore has the form of the following. We can get the common term out, that is minus omega t, and then we combine the uncommon term, and we can use Euler formula to expand this to be 2 times cos kx. So E1 plus E2 is e to the power of I omega t times 2 times cos kx. That's it. Very simple formula. And this is nothing but the standing wave waveform. If we draw a figure to describe the amplitude of the standing wave along the propagation direction, which is x, we see it forms a standing wave along the x-axis. And for a specific position, let's say, for example, x, the amplitude is set to be 2 times cos kx and oscillate at a frequency of omega. And at that point, let's draw a curve with respect to t. We see it is oscillating at the frequency of omega. Thanks for watching.